over 10 years ago, and then I've been involved in ever since, and every time I keep trying to get away and give it up, somebody says, but you could just do this, and you never disappear or get away. During the week, I work for a company called Park Signalling, the business development director, and I've been with that company for the last 5 years. I worked for them previously as a subcontractor in the past, but the company itself is 21 years old this year, so we have been with for some time. Park Signalling originally started by the original team members of the R&D department at Trafford Park of GEC Signalling. And when they unfortunately got made redundant, instead of relocating in the south, they set up their own consultancy. And here today we have Park Signalling. So, next slide please. So, I'm not going to read all these words verbatim, but we do a lot of good things. We have done a lot of good things in the past. Our core staff is growing all the time. We're actively recruiting graduate engineers and senior engineers at the minute. We're involved in all sorts of projects globally at the present time. We have got a number of part-time associates, and we are looking for some more. In the beginning, this product called Die Block. You all know what one of these machines is. It's a tyres number 12 instrument. It's actually my instrument. It's actually sat at Crew Unipark Rail shops after it was restored. But ultimately, for many years, since single line token working started back in 1849, this is what we used to see in a signal box or in a line side location. So one of our engineers who wasn't working for us at the time, he is now, a chap by the name of Robin Lee. He was involved with a heritage railway called the Ecclesbourne Valley Railway, and he was doing a degree in railway engineering, and one of the items that he developed was a digital token machine. So this is the concept machine that he came up with jointly with Park Signalling and the University of Birmingham. So it looks a bit different, but it's got all sorts of extra functionality on it. And everybody thought, this is a damn good idea. We have something that tells us if it's poorly or it's not working right, but it's still working. We ought to develop this. So Robin came in and spoke to our then managing director, John. What's his surname, please? Slim. Thank you. It completely went out my head. And John picked up on this, and over a period of years, began to develop the die block solution. But of course, that's all well and good, but we can't actually fit many tokens in there. And to a driver or somebody who uses them on a regular basis, it's a funny shape, it doesn't look right, it's not a token machine. So with a bit further development, we measured my previous machine and spent some time and came up with this wonderful device. So it's the same size as a tyres number 12 machine, it's the same shape, fits in the same footprint, and it looks very similar, but there's all sorts of additional features on it. We have afterwards two of these working down the bottom. I've got a number of my colleagues with me today, so you can play with them. They're all working, everything's up and running. So I encourage you during the course of the day to go and talk to my colleagues and see if you can break it. So we got to this point, and we thought, right, we ought to tell the world about this. So we held a proof of concept demonstration day at a place called the Ecclesbourne Valley Railway. And why did we do this? Well, a number of reasons. Robin Lee was a volunteer there, and the railway itself is very close links to research and development. Tescar RS is now located on that railway, and of course the BR Research Department did plenty of testing along that line during this day, and one of their historic relics, as you can see there in the picture, still remains on site, and it is still functional. It does need some work doing on it, and I plan to get that fixed in the near future. So, an ideal place to demonstrate this equipment, centre of the country, right next to a railway station, so you can get to it. So that's what we did. And here you see in this picture Robin Lee himself going through the presentation that we had at Hillfield Station, explaining the concept of the machine and how it works. And that's one of the machines that we had at the station building it works with. So this was, as you can see, March 2019. And we had high hopes to move this forward and get it out operational on the railway in 2000. Again, I'm not going to read this verbatim, so we'll leave it up there so you can work through. That is the basic concept of the machine, which really replicates the previous token machine. And of course, it's quite interesting that it's actually 100 years this year since the Abermule disaster on the Cambrian lines, where of course the driver took the token, it was the wrong token, and drove into another train. And of course, ever since that event, it was mandated by the Department of Transport that the token machine should be interlocked with the section signals. Okay, basic concept if you don't already know, and how are we doing for time? Are we okay?
Yeah, you crack on.
Thank you very much. I know you get upset if we don't keep the time. So for those who don't know, and I'm sure all of you in the room know about how a token machine works, but obviously you've got two stations with a single line in between, and the whole idea is you take one of these tokens out, but you can't take another token out, and it's for the safe passage of one train from A station to B station. If we go to the next slide, as you can see, sometimes they're in a signal box, sometimes on the station platform. In some cases, they're in a location case on a platform. For example, the Whitby branch. One thing I will point out, there is a subtle difference between a Tyres number 12 machine and this machine, in that there isn't a bell. There isn't a bell on it, and that's because the original concept was to put these in on no signalling key token signalled lines, whereby they're always using the telephone to communicate to the signal. Since then, different railway organisations around the world say, that's great, has it got a bell? Well, it hasn't got a bell, but haven't we moved on with communication with regard to the mobile phone or the fixed line? So it really depends what your railway's used to and how your railway's prepared to change to use this kit. Because you don't necessarily need a bell, and worst case scenario, if you really wanted a bell, we could give you a separate bell. But obviously something to think about with product development in the future is actually make provision for things that people will not inevitably say, but I want one of those. Unfortunately, it costs more, but still. So as you can see, in this arrangement, the signal provides a release, of which can be demonstrated later at the back, to the other instrument, and the token is taken out, we traverse the line and put the token in at the other end. Works fundamentally, works the same as what the previous machines would work. You can go to the next slide. Again, you can make arrangements so there's a release in either direction. We've sort of allowed for that depending on the actual site and the requirements on that site. But of course, the fundamental reason why we developed the token machine was for this next slide, which is in no signaller mode. Where you've got machines on either platform for coming out of the platform in either direction. And this system is a balance system. So as soon as you take one out, you can't take one out any other machine until you put that token back in at another machine. And there's a maximum at the minute of 6 machines you can have in a circuit as such. But we're looking to be able to develop that if there's a requirement in the future. Because these days, to be honest, where these are left, certainly in this country, we've not come across a configuration where there's more than 6 between 2 locations. With going up to 6, we can have intermediate machines for ground frames, so that's not really a problem as such. We've considered all of that and listened to the requirements in the first instance of Network Rail. But again, we've been talking to various heritage railways and other railway organisations outside the UK. You haven't got to lay a line-side cable, which is a big hindrance in any heritage railway or in the instance of Network Rail. We've tried to standardise it as much as possible and consider all configurations in the future, both in the UK and abroad. I've already said that it's up to 6 machines in a group, because really we've not come across anything bigger than 6. One big distinctive advantage is remote condition monitoring. So the system has basically works on 2 circuits. Instead of just a 2-core cable, it's got 2 channels that it can work over various means, which I'll explain in a little while. But all this can be monitored. So if you're having intermittent problems, this can be fed back to wherever, a control centre. It can even be a message on a mobile phone to somebody. That's a distinct advantage over the token instruments that are out there at the present time. Obviously, existing keys, although over the years there's been problems with the design and manufacture of key tokens, but the existing keys could actually fit into one of these machines. We've already tried it. The trial sites that are coming up where existing keys are currently in use, we've borrowed those keys and put them in the machines. And of course, the key thing is the signal and release doesn't release older machines, it's the machine that somebody's sending a request from. So there's some distinct advantages there with this kit. And that is really what our customer, as in the first instance, Network Rail, wanted for particular routes going forward. Because not only are they having problems with servicing the machines, because of course there's not so many people these days that understand them, the machines themselves have a tendency to become museum pieces by whatever means, and I shall leave that one there. And of course, from time to time, the machines get damaged. Within the last couple of years, there was a fire at Oxford where there was a ground frame that had a machine in and it's completely gutted. Okay. We've also put thought and consideration to this on a lot of the sites where we're looking to swap these machines out. There's the transfer magazine arrangement on the side. So we've considered that in the design of this kit, as you can see in the pictures here. That's Landilo, one of the existing token-ups. And that's of course our new dial lock machine with the existing kit bolted on. We don't at the present time do these transfer magazines, but depending on requirements, customer requirements, we do have plans to be able to manufacture those. And for those that don't know, these items on the side are for the manual transfer of tokens, for where you've got a lot of traffic in one direction. So a lot of tokens move in one direction and build up at one end. From time to time, these are manually adjusted by the signalling technician. And we've had quite a few inquiries about that kit alone. Key tokens, well of course in the tyres machine, inside you'll have a piece of metal that you put in the position of one of the 4 key positions, so you can only have those suited keys that fit into the machine. As you can see, we've considered that, and these come with each machine so they can be configured accordingly before they go out to site. We have had keys manufactured, and we've been working with a chap by the name of Graham Christmas in Network Rail, because he's been doing some research and changes within Network Rail nationally with regard to the condition and manufacture of key tokens, because over a period of time the design and output had changed and caused 1 or 2 problems. Okay. So the architecture itself, I'll let you just look at that diagram and take it in, but as such, and this is where I sensibly wrote some notes. So the dial lock machine safety functionality is performed by a 2 out of 2 architecture. Each safety processor controls its own shot bolt, which controls the removal of the key tokens, and relays which control the safety outputs. So there are 2 channels that go into each die block, and these can be connected up by various mediums. It could be a dark fibre optic cable itself. It could be a 4G or 5G connection. It could even be by the internet. So there are quite a few options how you can connect this up. You could actually, if you wanted to, connect it up with a copper cable, but that's entirely up to you and would cost a lot of time and effort to run that cable out. So the state of the shot bolts and safety relays are monitored by the opposing safety processor to that which controls it. Then any detected faults obviously come through the RCM indications and can be fed out and fed into a network rail derived product or other monitoring systems which are available internationally. Okay, next slide. So just going over the interfaces you can see that go into it and the RCM contacts that can be monitored. So considering a normal token instructor type number 12, this is a distinct change to the amount of things you can monitor on it. Tokens in, and as it said on there before it quickly changed, fully isolated. The voltage-free contacts are. We've obviously spent a lot of time going through cyber security issues. In fact, that was one of the things that has delayed this project moving forward because of the potential issues that obviously we've identified the risks and worked with our ASBO to understand those and mitigate them as much as possible. And if we go to that other slide, there you can see the Ethernet channel A and B, and then a third RCM Ethernet connection. So those Ethernet cables or connections are the ones that go to the outside world. Okay, how do we configure each one? Well, it's a simple little flashcard. We put the configuring information on one, and these are the cards that you put in mobile phones and cameras these days. And I mean, the size of them, the amount of information you can store. I think when we were looking at the risks and doing the analysis, you could easily store a year's worth of operations on the long storage file on one of these small disks. And it just so happens I was demonstrating these the other day and we had a problem. It wasn't a problem really because we took the login disk out, transferred the information to our colleagues in the office who told us what the problem was. Simple as that. But ultimately, longer term, we want this so the owners of this kit can be looking at this on a regular basis and understanding when there's blips and problems to be able to go to site if and when required to make sure that the machines continually work. That is a big step forward, being able to record everything that's happening in the equipment. And if you do have a catastrophic failure, of which we've never had one yet, catastrophic that is, the local person can work with one of our engineers in the office and understand that very quickly what's going on. Yes, thank you. This slide just demonstrates that obviously no signal and key token instruments are in use in the UK, and our equipment can function and interface to the existing standard TPWS circuits. So that's with obviously your aerials in the forefoot and your blue flashing indication when the aerial is suppressed. That's already been done. This kit interfaces with that and works without any issue. Okay. So through our work with the Romney Island Dymchurch Railway, we've found a number of challenges. Hence the reason why our initial machine is referred to as KT100. You can see a picture of the shot bolts, the commutator and the shot bolt arrangement. All very good, you know, in theory it works very well, but we had an opportunity to work with the Romney Island Dymchurch Railway to shake down this equipment to make sure it was fit for purpose. We had some challenges. Go to the next slide. That's just our manufactured board that goes into the machine, and as you can see, the actual machine itself is made from machine aluminium. It's quite a lot thicker and heavier than a Tyres number 12 machine, but it certainly is fit for purpose. So here we have pictures of the kit initially on the workbench, New Romney. And then the middle pictures, New Romney signal box, and over on the far side you can see it's Romney Sands, which is positioned in a location at the end of the passing loop behind the station building. So this was a really good exercise because Romney Island Dymchurch Railway had got a challenge to resolve. And we got some kit that could do that, but we needed to push it and understand its limits and find if there were any problems. And yes, there were some problems, which if we go to the next slide, I'll just walk you through these. Timescales. We've had some challenges with regard to the safety case and understanding all the risks. We had a change of team managing this, so timescales were extended somewhat. There was this pandemic thing that did have a slight impact, but what we found is we've committed to Romney Island Church Railway to achieve things by certain times, and things slipped to the right. Quite open and honestly, but again, working with the Romney Highland Church team, we explain the reasons why they give their feedback, and we work with them to get things correct, right, fit for purpose for their railway. Documentation was a big thing. That's tied in with timescales. That's taken quite a bit of time to get right, to get signed off by the ASBO, by the ISA, and I'm pleased to say, as we stand now, we're just waiting for certainly the site trial certification for Network Rail for 3 sites that I'll talk about in a bit. But we're just waiting for a final sign-off with our ISA to be able to pass that over to the Romney Island Church Railway, for them to complete their paperwork trail and their risk assessments to be able to give authorisation for that kit to go into service on their railway. But those two things together have taken some time and taken longer than we ever imagined, because of a number of things that we had to rework. Things hadn't been done correctly in the first place, being open and honest. And like I say, with a change of personnel and a slight impact from the pandemic, it has caused delay. Put down there, Swarth, the manufacturing of the equipment has been to a very fine tolerance. Although we've borrowed tokens and had trial tokens in the machine, because of a certain software issue that was resolved, the Romney Island Church Railway decided to do some intensive testing of our equipment. They wanted to see 1,000 operations, and yes, they quite happily did 1,000 operations, but because of the new tokens and the sharp edges we found on there, and the sharp edges within the equipment, it generated a lot of swarf inside the machine, which is it's good that we found that out before it went out to a number of other railways. We're working on that with changing obviously the tolerances, but it's something that normally we wouldn't picked up on that. So that was a really good thing that we found it now, so we can manage it going forward. 2 other things that I want to talk about. These haven't actually happened, but of course Romney Island Church Railway being down in Kent on the coast, we've talked about potential corrosion implications, and it's something we'll be monitoring on the equipment down there, but we've got no other information to go on. So it's quite important that when this equipment is signed into service, we're hoping it's very soon on the Romney Island Church Railway, that is something we'll be working them to monitor going forward. And one final thing that was never considered, the shot bolts that we used, only as going through all the safety case documentation again, only work down to a certain temperature, should be guaranteed to work down to a certain temperature. And the question quite rightly came up, what happened if we had a bad frost or a bad winter? What would actually happen? Well, we actually created a cold environment. We bought a big fridge, in other words, a test environment for our premises in Stockport. And we did quite a bit of testing, and there was, in theory, a situation where the shot bolts could be frozen open. So we're actually doing some work on a modification going forward and producing the KT101, the next version. And that ultimately will be rolled out as the machine to go outside in the future. However, the 2 machines that are the Romney Island Church Railway are the KT100s, and again we'll be looking at those and monitoring those. And we have agreed at some stage we will be swapping the machine that's outside over to a one that has been, how can I put it to be politically correct, upgraded to compensate for any severe environmental change.
Okay, thanks Ian.
My pleasure, thank you.
Right, do you want to bash into your next one now, because you're run well over.
Have I? Excellent. Well, we can save the video and show it on a laptop on the stand. Okay, the future. We've had the feedback from Stephen there. So we're developing a second machine, and ultimately we'll go to the second machine going forward. So wherever you put it, it's environmentally covered. But future projects, really excited to announce those three projects. Those three projects are going on the site trial certificate. We should have that resolved for Christmas. So Q1 next year we'll be rolling out the die block units on the Central Rails line, and that's the initial trial site. But the Dartmoor line that opens today, we had confirmation this week that when they start running through to Meldon Quarry, they'll be requiring die block instruments, and I've already been up there and done the surveys for that. And then Ralston branch up near Skipton, they want to increase the amount of trains that they operate on that branch in a minute, so they want us to put that kit in there. And that's just the stuff in the UK. We've been approached from other parts of the world. Bangladesh is the one this week about the possibilities of this kit out there. And I think once you get over the issue that there isn't a bell, because everybody sort of said they want a bell, most people are quite relaxed about it. But yeah, exciting time. I think last slide. Because I've run over, and I do apologise, I'm quite happy to take questions through the course of the day.
No, you're on till 25 to, but you had 2 presentations booked, you see.
Okay, well...
there was Mr P signalling and then Mr I Allison.
Okay.
So you had 9:45 till 10:05. Now you've got 10:05 until 10:35.
You've got to stand on that side now.
Yeah, swap sides.
Well, do you want me to do it in reverse on that side? Talk backwards.
Go back to that slide, that previous slide.
The previous slide, okay.
Right, carry on. Got it.
Okay, thank you.
Can I ask a question, Ian?
You may.
About bells.
Yes.
One of the reasons bell codes was mandated in a lot of cases was unambiguous messages as opposed to misunderstanding verbal communication.
That's right, yeah.
You say you've moved forward from bell codes by using mobile phones. I say that's a backward step because you're going back to ambiguous messages where, you know, in certain circumstances.
Okay.
Verbal communication is someone's opinion of what they heard.
Okay.
As opposed to a definite bell signal, which is why a lot of railways will still insist on we want a bell with a token instrument.
Okay, when we originally worked on this concept and spoke to Network Rail, it was all about upgrading the no signalling
I
key
agree,
token
yeah,
sections.
I mean the reason why it was developed, but if you're going to use it between 2 signal boxes, you're going to need a bell.
Yeah, we can provide a separate bell. My only, I would say, criticism about the project, because I wasn't involved with it right at the beginning, is we should have made provision for a bell in the design, and then it'd be there. Something we've picked up and have learned with new products going forward. Look at all the functions it did in the past. Make provision for it, but don't necessarily use it. You never know. Depending on the demand, we may adjust the design in the future. But at this present moment in time, it's the Heritage Railways that have approached me. It's a very small demand.
I agree, but you know, your possibility of alienating a demand that is there.
We can provide we can provide a separate bell. It just won't be part of the machine.
Over the whatever digital system you use.
Potentially, yes.
You know, not providing the token over a digital system and say, oh, by the way, you've got to run a cable for the bell.
No, we can use the link, but again, it's all down to demand and whoever wants it.
Ian, could I ask one question, please, about the Ralston branch? You'll be interfacing with York Rock over it?
Yes.
Yeah, that's fascinating.
Yes.
Do you think you'll get a Nobel Prize for this or not?
Definitely not.
Have a good day. The final time, it involved a lot of nines, essentially. It was like 99.99.
So then possibly things like that. It's all lanes and processes. And if they can, if you're indebted, just write a bit of register. You'll soon be able to make such a system that you want to do. just try and figure out what's the problem. Because I think one of the we'd run one of these we've got channel A going over 4G and channel B going direct, or maybe that could be going to a DSL router that's on a BT phone.